Hello friends, now we are going to study symmetrical fault analysis procedure. In previous class we have studied the fault analysis on any single equipment. Now we are going to study the symmetrical fault analysis on single line diagram. Means if we have been given a single line diagram means power system, and at any place any fault happen, then we are going to find out the value of short circuit current as well as the short circuit power. To obtain the fault current or short circuit power, we have this given procedure in which the first point is by choosing appropriate base values, convert all actual inductances into per unit values. Means on the single line diagram, selecting proper base values, convert all impedances into per unit equivalent reactance. Now the second step is convert whole single line diagram into per unit equivalent reactance diagram. So we have been given a single line diagram, and now we converted that single line diagram into per unit equivalent reactance diagram, and we have discussed the procedure of making per unit reactance diagram in per unit method chapter. So this task we have been completed and this is easy. Now next third point is now look for faulted terminal. We have to look where the fault happens, like here the fault happens. And then what we are going to do is reduce network into Thevenin's equivalent circuit across faulted terminal. When we spotted the fault, then what we are going to do is we are going to find out the Thevenin's equivalent across that fault. So Thevenin's equivalent, we know that this is AC circuit, so this will be ZTH and this will be plus minus VTH, and the if short circuit has zero fault impedance, then we can simply do that. So ISC we can calculate from here, that will be VTH upon ZTH. Or if this short circuit impedance has any fault value, then what we are going to do is we are gonna simply add load resistor, that is fault impedance ZF. You all know the Thevenin's equivalent. So this will be VTH, ZTH, and here it will be ISC. And ISC can be written as VTH upon ZTH plus ZF. What we have done here, why we took the Thevenin's equivalent? Because Thevenin's equivalent reduce the whole circuit into one practical voltage source. So either you can solve this by conventional method, nodal analysis or mesh analysis, or you can reduce this in Thevenin's equivalent, then you can find the short circuit current. And once we found the short circuit current, then we can easily find out the short circuit power. So here it is all about the symmetrical fault analysis procedure. Thank you.